This is the Amp Hour Podcast, recorded September 28th, 2016. Episode 317, a decoupling conversation. Welcome to an experimental episode of the Amp Hour. This one we're going to be doing with a call and response kind of thing, almost but not quite an homage to the debates that are happening, at least in the States, and the absolute garbage mess that those are. No, this is actually because Chris Gamble, I'm in Belgrade right now, and the time difference is always really difficult between Europe and Australia, as we've talked about in the past. That's why we're usually limited on guests that we have on from Europe, because having me and Dave and a guest from Europe, we're spanning 3 time zones, almost splitting the world into thirds, and so that makes things really, really difficult. So now that I'm in that third, we thought we would try a experiment here where we talk about things in the news, things that we would normally do on any show anyways, and then basically respond to one another kind of remotely. It's kind of like almost like a voicemail box, for lack of a better word. And we're going to, well, we don't actually know which stories we're going to be talking about, or stories on the subreddit, or things that we would have talked about anyways. We're just going to kind of jump in and talk about different things, and then we're sending each other files, and then we're responding to them. And the interesting thing there is that there's no prompting. There is editing, of course, but we're not going to cut anything out. It's just going to be hopefully some brief question and answers, not even question, it's some brief call and response kind of about things that are happening, and you'll get to hear what it sounds like when we're not talking to each other directly. If you've listened to the show in the past, you know that me and Dave, we feed off each other's energy. Maybe we'll get upset, or maybe we're discussing a topic, but it's really different when this is more like writing letters to one another, and I think that's actually kind of interesting. I have no idea how this is going to sound. I mean, I'll know from editing, but we're going to put it out anyways. And it's very likely that this will not be an hour. So if you are expecting an hour, I apologize. And because I'm the one traveling and I forgot to set up a better recording time or situation, I suppose this is on me. But that means if it's awesome, that's also on me. All right, so let's launch into this. We're going to just, we're going to copy stuff together, or push stuff together, and see how it goes. Hope you enjoy. Let us know. We always love feedback. Feedback at theamphour.com if you have email, but even better is in the comment section. Let's try this out.
Now, I really like this story because it's a good example of how FPGAs can be inserted into designs when you just don't know what you're going to use it for down the track, but let's put one in anyway, and because it's going to be a good thing to do. It's going to be really handy in the future. We'll link to the article down below, but Microsoft have been doing servers for their Azure services. I don't know what Azure services is. I don't know, some AI thing or something, is it? Anyway, Microsoft have their own servers for doing this sort of stuff, and for the last 6 years, it's called Project Catapult. I guess that's pretty apt, is an effort to accelerate cloud computing through network FPGAs. And what they're doing is, when they built these servers, they went, well, okay, we've got our processor. Instead of just hooking the processor in the server directly onto the, directly onto the internet, we'll put an FPGA in between. Right? So all the traffic is funneled from the processor through the FPGA and then onto the network, the cloud, the internet, the interwebs, whatever it is. So all the traffic was funneled through there. And up until this time, I believe that they haven't actually really done anything with it, with the FPGA. It's just funneling the data through. But now that they're saying they're experimenting with actually re-updating the firmware, the configuration of these FPGAs, hence their name, field programmable gate arrays. That's a good thing about you can do this. So they can just remotely update the configuration of these FPGAs. So instead of just passing the traffic through without actually doing anything. They've got all that logic in there that they can actually do hardware acceleration and tasks to take it away from the processor. And, they're saying you can get speed increases, depending on the task, of course, anywhere from 10 to 1,000 times, but it's usually in the low, tens or something like that, says one of the head architects at Microsoft working on this sort of thing. But that's a massive improvement. Your existing server architecture, and then just to be able to suddenly increase the ability to process stuff by a couple of orders of magnitude, an order of magnitude or more. It's just amazing, and the power of this thing. But as noted in the article, which we'll link in down below, they said you have to be really careful, though, because with great power comes great responsibility, of course. And if you don't get the configuration, if you don't get that logic right and you push out that change to your 100,000 servers or whatever it is, and there's some little niggly thing wrong with it, wah, 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 yeah, the whole house is just going to come crashing down. And yeah, it's a real concern. But if you do get it right, then you can speed up stuff and do processing inside these FPGAs instead of on the processor, and it can be order of magnitude or more, or several orders of magnitude faster. So, terrific. I love this. It's a classic case of thinking ahead, but whacking an FPGA, because these servers are very expensive, so cost isn't, they're probably not a major factor. So they put them in, and they can probably do some real funky processing and AI type stuff that's real, parallel tasks and things like that FPGAs are really suited for, instead of sequential processors, which is what your average processor, Intel processor, I presume they're using in these servers. And they're Altera FPGAs now, Intel Altera FPGAs. But yeah, I thought that's really cool. That was a real smart move for them to do that 6 years ago.
Yeah, that's a good point at the end there about Altera, like 6 years ago. This is so if people don't remember the timing, Intel bought Altera just in 2015. So maybe this was like their tryout as well, where they're like, oh well, maybe this is actually what spurred them on to go on and buy Altera and trying it out. I remember I used to use Altera FPGAs for some stuff, and they had some interesting. I remember they used to push this thing where they would do the C to H, what it was called, where you'd be writing stuff in C on like one of the softcore processors in there, and then you could like click a bit of code or highlight a bit of code, and basically it would try and generate the hardware for you, where you basically create a subroutine. The way to think about it is like if you think about an add or a subtract, or just an arithmetic operation that happens in a processor anyways, right? Basically, if you make that chunk small enough, and if you're doing this bit of processing often enough, right? So say you're adding two, and you're adding whatever input number to another input number, and then you're multiplying the whole thing by another number, right? So it's like 3 operations there. Basically, if you're doing that often enough, you can start to make that into a direct hardware block, and really speed that up, because now you're not chunking it through the processor each time. You're actually creating custom hardware that is dedicated just to that, right? So now you're using multiply accumulators, or you're whatever your operation is. You're basically going and you're creating that as hard logic, right, with dedicated gates to it, instead of pushing it through the same path over and over again, right? Because that's really what a processor is doing. It's using the generic hardware, and then it's writing. You're basically using the generic hardware to do a variety of tasks, but that's usually much less efficient, like Dave mentioned, and so this is interesting. I'm not sure what it would actually end up looking like for network traffic. I mean, I'm sure that there's, maybe some kind of port masking or something like that, where there's got to be some kind of net benefit to doing this, but I'm just not privy to what that actually looks like. The interesting thing is that this is probably, and I think the reason that Intel is interested in this kind of stuff anyways, is that, if we start really butting up against Moore's Law over time, right? A lot of times the answer was just, we'll just wait for it to get faster, right? You wait 18 months and you get the new set of chips in, and Moore's Law has taken care of you. If we start running out of that, then the thing that's going to get us more efficiencies is spending more time optimizing code, or in this case, optimizing code and turning it into dedicated hardware. And this is definitely one of those paths forward. like Dave said, the cost is definitely higher, but that's not that, for servers at least, that's not a big deal. You might not be doing this on your little internet connected widget or whatever, but especially because dedicated and flexible logic, flexible logic, not dedicated, is definitely expensive in terms of transistors, but also power. But either way, if you're in a situation like this where you're plugged in, you can, and you have the time to go and write that customized logic, it could really have some benefits, and especially for something that's high stakes like traffic. The next one for me is kind of a softball, and it might end up that we both end up talking about it, but, each of these we'll end up talking about, but we might end up recording these before we know. It's near and dear to my heart because I actually have one of these things, and I talked about it on the show before. So the narrative clip, which I was super excited about when I first got it, they filed for dissolution, and which means that the internet connected device that I was excited about no longer has internet effectively. And I don't think I talked about it since it was on the show, but obviously this is yet another cautionary tale, both as a consumer, and I should mention I did get this thing for free, so I'm out a lot less dollars than anyone who actually bought one. As a reminder, the narrative clip is this little, it's like probably, 10 centimeters across, square rather. It sounds about right. Maybe a little bit less. Anyways, so maybe 8 centimeter by 8 centimeter by like 2 centimeters. It's basically a little clip that you wear on your shirt, and it's got a wide angle fisheye lens on it, and it just snaps pictures at whatever frequency you set. And so every 10 seconds or 60 seconds or whatever, and then you kind of scroll back through photos over time and see where you were. And the idea is you're just kind of wearing it there. I like this idea because it was the only part of Google Glass that I liked, of like not life logging, but kind of just reminders of where I was throughout the day. And that's nice for meetings and stuff like that. As a practical note, it took terrible pictures. I mean, it was like, if you think about where your shirt collar is most of the time, it's not pointed straight ahead. The thing that was nice about Google Glass is that you were always, wherever you were looking, that's what you were taking a picture of. Anyways, so basically they announced that this is shutting down. They announced that they will release some kind of software to jailbreak the photos that are on a narrative, that and they can download also anything that's up in the cloud. But I think we've talked about this in the past, where it's like, at a certain point, any system where you don't control the entire chain is going to have a weak point, especially if the company goes away. Now, this is a very low... this is a very, very low stakes game, right? It's just photos, it's poorly taken photos, but it's interesting because that we've talked about the same thing with firmware loading onto devices before, right? If you lose control of the firmware uploading capabilities, then your device is just dead in the water. And now there's a bunch of devices that are out in the world where I can't go in. I think it's an STM chip on board, but I don't think I can go in and jailbreak this thing and use it for anything else. It's just a piece of plastic now, effectively, that's going to sit on my desk, even though it was already in that realm. So I wonder, is what is the output of this? What is the practical implications of doing something like this? Do we demand that services give access at some level, like an API access level? The thing that I wonder about, I really wonder about that, because in this case, it was a Bluetooth connected device, so it went through the phone, and the phone had to bounce photos up to the cloud. And you may remember as well, there was some kind of GPS tagging capability, but that might have even been for the phone. I don't remember the conversation there, but it's basically just another one bites the dust. This is another cautionary tale of internet connected hardware. And if you were following along the story, they had a lot of delivery issues as well. So that ended up maybe the hardware schedules again killed them like anything else, like my manufacturing woes in the first thing that I talked about. So, Dave, what do you think? What should we do? What should we do about products like this? I mean, like, do we boycott at the beginning? Do we just say nothing internet connected? What do you think?
And another one's gone, another one's gone, another one bites the dust. Hey, we've got to include that clip from Queen. Come on, Chris, do it. Screw copyright. Another one's gone. This is not the first one we've seen. It won't be the last one. I talked about this on the Amp Hour before. I can't even remember the name of it now. I had a Internet of Things connected thermometer in my lab where it'll log the temperature of the lab and everything, and it posted it on a website. And everyone could look at the temperature of my lab. It was really cool. You could see the air conditioner turn on and off in these 5-minute cycles and things like that. But the service that the data was being put through, whatever term you want to use for those sort of things, the data server, that was bought out by somebody else. So it bit the dust that way in terms of software. And then I'm not sure if the company who made the thing just abandoned it, and so it became useless. So the company might still be around. I can't remember their name, making new hardware, but they're almost disposable now. They just don't care about the long term, and we've talked about this before again and again and again, and it's just going to keep happening. And really, there's nothing you can do about it. You just need to accept this risk that an Internet of Things device you buy now, in 10 years' time, I think we put bets, like 5 years' time, you're X percentage likely for it to not be working anymore. 10 years is almost like 90% guaranteed. 15 years down the track, I don't know. It's just like it's 99% guaranteed not to be working in 15, 20 years' time. And it's just ridiculous. And if you devote your entire house to this thing, there's people who've wired, I think we had this on the show actually, people wired up their house with the Internet of Things, all internet controlled anything, and then the company went bust, or they changed the server and nothing works anymore and you're screwed. Well, it's your own damn fault for jumping on this bandwagon, especially people like us, hardware engineers who know and understand the risk, who can appreciate the risk in these. And if you can't see the risk in this, then you're not a very good engineer. So it's different for the average consumer. The average consumer buys it and thinks, wouldn't even give it a second thought, wouldn't cross their mind. And that's, fine. Do they need to be protected in some way by some laws, legislation or something like that? No. It's the marketplace is going to sort it out. People need to learn this the hard way. You can't legislate this. If a company goes bust, it goes bust. If a data server changes direction or goes down, you can't force a company to stay on a certain path in a certain direction just to keep users happy. It's just inherent in the risk of the thing. There are some parallels here in terms of the right to, maybe not the right to repair bill, but other bills I think that have gone in the US. That, and in fact, there's even one here in Australia where large companies must keep spare parts for X number of years, and things like that. And I'm not quite sure the law behind that, but I believe there is something in place for something like that, especially for white goods and things like that here in Australia. I think like washing machines and things like that. There's an expectation that you'll be able to buy parts down the track, and it's a similar sort of thing that you'll be able to maintain your product. In this case, they've done the right thing, and they've got a tool that you can download it, but it's just like nobody gives a toss because the thing they bought doesn't work anymore, and you can't legislate your way out of this problem. Buyer beware. People need to, I hate to say it, but the average consumer probably needs to be, hit in the gut with this thing that, this is a real problem. Maybe there needs to be education so that they understand the risk, but your average consumer doesn't care, but your hardware person should, and they shouldn't complain about it. You guessed it, there's another low-cost pick-and-place machine on, yes, you guessed it again, Kickstarter. This one's called the Chipsetter 1, a desktop pick-and-place machine, and it looks pretty funky, and they've got 73 backers already, which is really quite surprising. I'll explain why in a minute. They've raised 54,000 Canadian. Hi to our Canadian listeners, and they want 140,000 goals. So and they've got 28 days left. Whether or not they'll get there, I don't know. But it's like in the order of 4,600 Canadian. They're sold out, so $5,000 Canadian, something like that. I think it goes up to $6,500 Canadian, something like that. So I don't know, what's that, $5,000 US or something. So it's a pretty pricey pick and place machine. And this is one of the things, if you're doing a Kickstarter like this, getting people to risk like $5,000, that's a huge amount of money to put down, and hope, cross your fingers, hold your tongue at the right angle that they'll actually deliver the thing. So I'm actually surprised they've managed to get as many backers. I think most of those backers haven't actually bought the machine. They've just bought bought them a coffee or something like that, for $5, because they just want to support the idea. I don't believe it's open source hardware. Can I type in open? Nope, there's no word open there at all. So it's not open source hardware. And it looks like they've got reasonable people behind this sort of thing. It looks really good. And yes, the key, of course, to a pick and place machine, the viability of it, is having the feeders. And it looks like they've got their own design custom feeders. They actually look quite reasonable. And there's a ton of them. I don't know how many it supports, but like 20, 30 feeders or something, 20 odd feeders at least. So it does look really good, and it can support trays, and it's got vision and everything else. It looks like a reasonable pick and place machine. It doesn't, from the videos, it doesn't look particularly quick. So they've got lots of data on how many components per hour and stuff like that it can place. I'm not sure if that's entirely accurate, I don't know. Anyway, 600 parts, 300 components per hour. Oh, no, sorry, that's by hand. The chipset of 1,250 components per hour. We'll see. Anyway, it didn't look particularly quick in the videos, but hey, it does actually look pretty professional. It looks like a 3D printer. All the box type of thing. All the feeders are all inside. And it looks all very neat and tidy. I don't know where the waste goes from all your feeder tapes, but anyway, it does look really funky. And so it looks like they got their act together. So and because it's on Kickstarter, they do have a real prototype. But whether or not, I think they might be 3D printed and stuff like that. So if they're 3D printed their feeders and things like that, well, that's not going to work, long term. They'll have to get custom molds and stuff made and things like that. Anyway, it's another pick and place machine, and I don't know. They claim the software is the big thing with it. It's just one-touch setup, and I'm calling BS on that. There's no way you can do a one-touch setup. It's just no. Anyway, they're talking up that sort of side of things, so it'll be interesting to see, interesting to follow. But I don't know if they'll make their target of 140,000, because that's a lot of money to plonk down on a hope that they might actually deliver. But hey, good luck to them. Check it out. It's the chipset of 1.
I think your eye caught the same thing that I did with those feeders. For sure, that is by far the most important and interesting piece. And like that, you talk to people who are doing. We've had people on the show before, but I remember when we talked to Jonathan from PCB&G, and we've talked to other assembly people before. The feeders are often the expensive part, right? So it's like at least $500 a feeder, and that's something that you want the most of, because you want to, if you could, you would put every part in your library as an assembler into a feeder, because then you're just ready to go. Your setup time drops dramatically. So if they really are making an innovative new way to get feeders, and like you said, if the wastage and everything else is on point there with making sure you can pull the tape through and handle all that stuff, that is often a big source of strife in assembly anyways, is just kind of how all this stuff happens. But if all that stuff is working out well, that could definitely be a key point of innovation here. There is a bunch. So first off, people should definitely go look. They've done a really nice job with animated GIFs all the way through, kind of just showing the pics and the stuff like that. But when you see the up close, you can definitely see a lot of the stuff that they've designed here, like the holders and things like that. A lot of that is 3D printed now. Like Dave said, I don't know if they're going to switch over to injection molding, but either way, they're definitely They're definitely iterating rather. By creating 3D printed versions of all this stuff. In terms of the money, I don't really know. So I double checked Dave's math there. It's actually 10 people have backed the main machine so far, and that is, that's understandable. That's not many people, but these are big machines. I think actually the interesting thing is comparing it to another recent Kickstarter thing, which is the water jet. That was the Wazer, I think. So let me see if I can find this. The Wazer was announced a while ago, but the interesting thing is that this. Oh yeah, so it had a $100,000 goal. It's already 1.2 million, and so just saying, "Oh, it's too expensive," is not quite there because obviously this is a pretty similar price. It's $4,000 for the cheapest, or maybe $3,600 for the cheapest one, and I would argue that a pick and place is probably more useful. I think it's just less accessible, right? So the Wazer is basically talking about like it's a laser cutter with instead of a water jet, right? But and people just don't have as much desire for the pick and place thing, or maybe it's just about accessibility, right? People say, "Oh, I definitely can do assembly myself if I really need to," whereas cutting out ceramic or metal by yourself in some kind of pattern shape, it's less accessible to people. So it is interesting as looking at these two things together, why one is so much more so much better funded than the other. I think it's just because not as many people think they need a pick and place, and I tend to agree with that. I mean, like I could have, if I was given the choice between the two, if someone said, "Here's $4,000, you can either have a water jet cutter or a pick and place machine," I would probably pick a water jet cutter as well. So this is definitely an interesting one. I hope this pick and place does well, because it could make it more accessible. It's definitely somewhere between the Neoden TM245s and somewhere like a low end professional pick and place. So that's nice, but we'll see how it all works out.
Someone's in big trouble. The entire state of South Australia, here in Australia, obviously, and yes, it is down south, is without power, and it has been for the last day and a half or something like that, the entire state. And if you don't know how big South Australia is, it's over 1 million square kilometres. So that's bigger than Texas at 700,000 odd square kilometres. So the entire state is without power, because apparently they still don't know exactly the reason why, but we can touch on it. They do get their power fed from interstate, and the grid just shut off. They're having a massive storm there at the moment. It's like 1 in a 50-year storm. Really terrible storm. And that took down a couple of major power lines or something like that, possibly coming into the state. And there's some automated breakers which tripped and everything else, which is fair enough, but why they didn't have enough capacity internal to keep it going. But everyone in the entire state is without power. So it's chaos and mayhem and zombies in the street and, people stuck in lifts and all sorts of stuff. So, how does this happen? Sydney where I am, has a very robust power system. I asked this on the forum. Can anyone remember the entire Sydney basin ever going down? And the answer is no, not in the last 50 years. And even then it's tenuous back then. It's like little pockets go out here and then. So you might have 10 or 20,000 people, without power for a day or something like that. But it's very robust. It rarely ever goes down. Personally, I've never experienced more than a half-day power outage, and then, if you go to the next suburb, they've got power, so it's fine, But they have not been able to fix this thing yet. Not quite up with the news this morning, but I believe as of earlier this morning, it's still like 2 days or something, and they have not been able to restore it. So it's not like they can just reroute it somewhere else, but anyway, and now there's a lot of talk about, because South Australia has made a real big push towards renewable energy recently, which is fantastic. But Now some people are saying they went too far and compromised the robustness of their grid, and hence this is a result. And apparently there's some news article about the government's begging one of the coal-fired power plants, which they forced to shut down, begging them to come back online. And, and people were warning about this apparently just like 6 weeks ago or something like that, that the grid is not, going all renewable could be a problem. And, well, it's not if you architect it in the correct way. So, yeah, some systems engineer hasn't done their job, or maybe they did and they warned, and the engineer in the corner's going, hey, I think there's a problem, to, the powers that be, and they go, shut up. This is all about politics and renewable energy and everything else. And but the grids are really, really compromised, and it could easily go down and take the whole state out. Shut up. Really? No, you don't know what you're talking about. Anyway, so someone's in trouble. So there's going to be a lot of fallout from this. What's the worst power outage that you've had personally or in your country? Australia's got generally a very robust power system. As I said, especially here in Australia when they built the Snowy Mountains scheme way back. I'm going to have to do a site visit on that, but yeah, which handles peak loads really well and stuff like that. It's a hydro scheme. So anyway, let us know down below. Somebody's going to get their ass kicked for this one.
Yeah, I saw these news stories about South Australia. I think lightning is actually is an acceptable response for why your power goes out. You actually, if you don't know, one of the largest power outages in the States was back in mid-2000s. We may have mentioned on the show before, but it was actually due to a squirrel. And I was just reading online, there's actually a well-known phenomenon where squirrels take out they take out large swaths of stuff. They blow a transformer. I think your assertion about things should be more robust. I think these things are houses of cards more often than not, right? So the one that I'm talking about, at least by me, was so it looks like it was New York, Pennsylvania, Ohio, Michigan, and a good chunk of Canada and stuff further east rather. It's called the Northeast Blackout of 2003. And it let's see, it was caused by a software bug in the alarm system of the control, blah, blah, blah. It was something with a squirrel, though, too. I definitely remember squirrels being involved there. And so there's another, I was just Googling squirrel power outage. Apparently there was another one in 1968 caused by the Great Squirrel Migration. And so I'll link both of these things in. I just don't think, I know that, like you said, someone might lose their shirt over whatever this one is, because that is an entire region, and especially in Australia, I'm sure that I'm sure it's starting to warm up there enough that it's really affecting things, and especially because everything's so electricity based these days. But I don't know. I think if it holds up under most lightning storms and then one takes it out, a 50-year storm takes it out, that's better than saying a squirrel killed our power. All right, my next topic is you'll know it when you hear it. It's I'm a little out of my element, but I think it's actually interesting because I already talked about the narrative thing as a connected device. This is from the files of Nobody Is Surprised at All department. This is about IoT devices starting to participate in botnet attacks. Now, I feel a little bit weird because I don't really consider the devices they're talking about IoT, but really they are. So anyways, there's about 150,000 IoT devices reported to be sending packets like crazy at this hosting provider. And they said they got up to like a gigabit per second of data that they were throwing at this provider, where your server is just going to fall over under that kind of load. But a lot of that came from CCTV devices and DVRs, right? Both of which are, high bandwidth, high enough to send, nice video streams and stuff like that. But basically, they were using that as throwing packets, basically like a bunch of water guns. If you had enough water guns shooting off a mountain, off a cliff top, it's eventually it's going to be enough water that it could probably destroy something. Yeah, so they say IoT. I like I said, I think that's a little bit. When I think IoT, I usually think about like sensor motes and stuff like that, or Wi-Fi connected stuff. Some of these are probably wired as well, and so I don't think that a particle photon is going to be there's not going to be a botnet attack from that anytime soon. But what it does is it just reinforces the same thing we always hear about, which is security issues in these devices. Basically they left all default passwords. There's not anything. There's really no security protocols at all. And you read about this other stuff too, right? So I've interviewed Sammy on the show before, and he was talking about a lot of the vulnerabilities in hardware, and it's just not it's not that challenging because the people are not yet paying for it. And so what I wonder though is, is there at least is an industry for it for software, and I know it's rising as an industry for hardware, but I think what it really comes down to is there some kind of regulation that should come around it? And not even regulation, but more like, because I think there are people that are trying to do regulation. It's more about, is there general practices? Because I'm sure that some of our listeners are working on connected things, right? I talked to Omer Kilic when I was in London about their connected thing, right? And that if you get a sufficiently large number of devices in the field and they all have the same password, not saying that theirs did, I'm just saying that if someone didn't think about that stuff, then it's like, well, what do you do then? And so how do you? I guess you have to like hunt down a security firm and think about that. I guess the real question is when do you really start doing that, right? Because it doesn't seem like this is all at the hardware level. It seems like it's more at the upper levels, and it seems like it's for devices that are using higher level software anyways, right? So full operating system Linux based devices. However, we keep seeing more and more devices that it's like, oh, well, Linux is basically free, or it's low powered. So, it's low power enough that you can have Linux on it, right? Use a BeagleBone Black or something like that. And then if you start not locking down your system properly, well, you're basically putting a bunch of traffic, a bunch of, garbage traffic generators on a network, and you could really start to mess stuff up.
One major question here is, well, who's actually responsible for this, for, taking care of security and stuff like this? Is it the DVR manufacturer? They sell a DVR and it hooks onto the internet, but where does their responsibility start and end? Is the solution as simple as simply forcing the user, designing the product so it forces the user to enter a password during the setup? You take it out of the box and you can't use the thing. It does ruin the out-of-the-box experience, but that's the price that the consumer might have to pay to ensure that this problem doesn't exist. But does the consumer care if their DVR has been taken over, their Internet of Things light bulb has been taken over, and it's sending out packets to the internet and trashing some server on the other side of the planet? They don't care. Unless they don't know nor care unless their bill comes in from their ISP and where did all this data come from or something like that. But because we have data caps here in Australia, so you go figure. Anyway, so that's something to ask. Where does the consumer's probably not even going to care, and the manufacturer's probably not going to care. It's the person's that ultimately the problem becomes the person who's being attacked. And once again, can you, as I talked about before, can you solve this with legislation and things like that? I don't think so. The market just has to sort itself out, and this one might be a hard one to sort out because, the manufacturer, nothing comes back to them, really, apart from, some media exposure and going, this, Cisco router or something has got some flaw in it and it might make the headlines. But apart from that, if it doesn't, if their name doesn't get dragged through the media mud, then they're off the hook. The consumer's off the hook. They don't care. They don't even notice that their Internet of Things light bulb is a zombie and is attacking something. And nor should they, I guess. So, manufacturers probably could step up to the plate. And as I said, just change the user experience. When you plug in your light bulb, you've got to set up your own password and explain to the user why this is important. security is important. You don't want it to be hacked. Maybe you can put the fear of hacking into the consumer, perhaps. I don't know whether or not that's going to do any good, but yeah, I don't. This one's a tough one to solve, I suspect. There's security and there's a lack of, there's security as in trying to beat security. You don't use a high enough hash encryption or something like that. And that's a manufacturer thing. They've got to choose a good encryption and stuff like that. And the other one is just the simple password vulnerability. Your standard router. I just bought one the other day for the new office that I'm in here, and password, username admin, password admin, and most people will not change that. So, and I didn't use the install disk, but I'm pretty sure the install disk won't force you to change it or whatever. Maybe it does. Maybe they could do that, but hey, of course I changed it. It's some 20-character long thing now. No one's ever going to guess it. So unless there's some hardware, some workaround hack for that router, I'm going to be pretty safe. But yeah, this ain't a easy question, I'm afraid. Well, what do you know? Who would have predicted this one? A company that we've talked about quite a few times, Upverter. They're the online EDA company where you can, your schematic and PCB CAD software is all online. It's all web-based and everything's stored on the cloud and operates from the cloud, and, you don't have any dedicated software on your machine for doing your EDA stuff. And what do you know? They have had issues. Who is it? Workbench Throwaway on the Reddit, that's his username, his or her username, on Reddit has complained that they can't export schematics for over 18 days now, and there was been no response from Upverter or their support forum, other than that they're saying, and I quote, "We're working on interesting projects." And I'll quote again, "I'm not sure which is worse, my schematics and layout being trapped, lost inside Upverter, or Dave being right about the whole cloud model not being suitable for EDA." Yeah, well, herein lies the problem. When you've got your everything online, operating online like this, you are 100% reliant on A, your internet connection, and B, their server being up and having no issues and stuff like that. And it works at the massive scale for things like, Gmail. Like, I'm not against these sort of things. I've been using Gmail for, 7-8 years now or something like that. I made the switch to completely online email. I've had very few issues, and I do the online, do a lot of documents online as well, using the Google Docs online thing and stuff like that. But yeah, CAD from these, I hate to say it, but these smaller companies, they don't have the same resources and everything else to make it necessarily as robust. Although the good thing is with the small companies, they can often move quicker. Now, I don't know why they didn't move quicker on this, but not being able to export your stuff for 18 days is just ridiculous. So yeah, you're trapped. You can't export anything. You can't do any work. Imagine that. So if you had a local software working locally on a machine, you don't need any internet connection. It just works locally online. And the only reason you might need the internet is to go to DigiKey and look up parts and search for data sheets and things like that. So yeah, therein lies the dangers. Let that be a warning to you of these online CAD systems. Can we say I told you so? Maybe. Anyway, it did have a happy ending. After a couple of weeks, they cleared whatever processing backlog they had, and Workbench Throwaway can finally download files. Yay, Upverter. Well done. And that won't be the last time we hear about stuff like this. So I don't know what went wrong there. It'll be interesting to find out.
I think that's a good point about the resources and the companies there, because I think what we're seeing with Upverter and other companies like it, like I think that they've been focused. The reason that this person who was having trouble getting exported was actually just because it was an individual, right? And I know that they've focused more on companies, and if you see their concierge service, which is a cool idea. That's all kind of focused towards companies, and that's really where the money's going to be, right? So it seems like it's a, more of a business model thing as well for them, where the companies are going to be able to pay big licensing fees. That's a lot of CAD software anyways, right? So that I can understand how that happens, but it is unfortunate that it took that long. One of the things that I had pointed out with Upverter is that their strength for a while there was the fact that they were working on so many different exporters, importers, stuff like that. But yeah, it is that is a little scary when your designs get like completely locked in there and you're like, guys, yeah. And we have talked about this to death probably, but I've written about that too. I actually tried out Upverter on a plane just to see what that looks like. And like you said, Dave, it's partially you need internet anyways to get to data sheets and stuff like that. But at the same time, when your boss is screaming at you to get something done, if your internet's down or your design's locked up because of an outside company, that's pretty scary. So some people might know that I've been working on the Hackaday Super Conference. That's something I do for my work. And an interesting piece of that is that I've been working on the getting the badge manufactured, right? And that's a big part of a lot of conferences is, they want to have blinky badges or interactive badges. People that have gone to DEF CON before know that they add all these puzzles in, and those are often, so like Joe Grand did some of the early electronic ones, and then, I forget his name, Lost Boy, I think, is the one who took it over, but it's often sponsored by Propeller, and they make just tons and tons and tons of them. And so I actually did the Super Conference badge last year too, but that was really simple. It was just a blank PCB with some prototyping areas, and then people kind of hack stuff onto it. I actually rather like that. I really like that idea of, just complete blank slate, but it was also because we ran out of time. This year we actually planned ahead, and Voya, who we've had on the show here before, also when I've been in Serbia, he designed the badge, and if you saw, there was I guess I could have posted a link to the Hackaday post about the badge, but basically it's a PIC-based design, and I've got it in front of me right now, and stuff like that. It's, it's a PIC-based design with an accelerometer, and it's got IR send and receive type of stuff, and a bunch of LEDs that can be used as a screen. And so interesting badge. I've seen some of the other ones that have been done for other conferences. We talked about the one that was based on the HackRF, I think for CCC or some kind of other hacker conference. But basically, hardware as a badge for a conference is a very common thing these days. And this thing that I'm working on is no exception. I've been working on the manufacturing side of it, though, is actually getting this thing made. And the thing that I wanted to talk about and kind of asked Dave about, or I would have asked Dave about if we would have been talking, has been about the sourcing issues for regional stuff. So it's been really interesting because Voya is here in Eastern Europe, and he's been sourcing using a lot of local distributors, stuff that he knows, and people that he trusts, really, because he uses manufacturing. But we're not manufacturing here; we're manufacturing over in the States. And so basically, for a while there, I was basically really struggling because I was thinking that we're going to have to get these parts somewhere else. I didn't know if I could export or not. I had a couple interesting online experiences where the sites that I was trying to buy from said that I couldn't export them or couldn't move them overseas or anything like that. And so I started to get really worried, and especially thinking about, there are some export restrictions on components because of lawsuits or weird stuff like that. But then I later found out that it was basically they just didn't want to sell that stock outside of the region because they wanted to make sure they kept it here. Anyway, when you're starting to do a global supply chain, I was actually kind of, not that this is a very small microcosm of the whole thing, but I was thinking about it where people design something and then they take it over to China. It's kind of the same, except I was going in reverse. I had a bunch of parts that were available here and design or ready for this market, and then there really weren't any replacements that existed in the States, in terms of stock at the standard, even Aero, Avnet, anyone like that. They were available, but you'd had to do standard lead time, 6 to 8 weeks, and definitely nothing in stock. And so it's been a bit of a struggle. I actually ended up just got it resolved the other day, and that felt good. But I just wonder about that, like if it's almost dangerous to, to work outside your region in terms of not where you are, but actually where you're manufacturing, right? So if you are, say you're going to China for manufacturing, it's almost like you have to go there, because if you spec in parts that are only available from like Mauser, they have to ship from Dallas to China, right? Or if they're only available from DigiKey, they have to ship from North Dakota to, is it North Dakota or Minnesota, wherever they are, the Thief River Falls to China, right? And same thing here, where a lot of these parts were only available in Eastern Europe, at least in stock, and they're great parts, but they were only available here, and there's cost differences and shipping and taxes and import duties and all that other stuff. And so it's been an interesting challenge. I'm probably going to end up writing about it at some point here, but I guess the question is do you have to buy parts from a distributor locally? I mean, basically, this is also another thing that's interesting about this is at quantities. This is about, I think we're doing about 300 boards, and this is at quantities where you can still get away with distribution. I think that's another thing that I'm realizing is that, a couple of things on here, it was basically getting towards, I should have been negotiating at the vendor level, and I should have been ordering parts at the 8-week mark, and basically it was a brief reminder or a brief foray back into the manufacturing world where real timelines, and so if you don't plan for that, you can get in trouble. So again, the question I guess for Dave is, do you have to buy parts locally, right? I mean, Dave's done manufacturing in Australia, and how does that end up affecting it? I think with DigiKey, it's a lot of people do that, and they end up shipping it wherever, but just wondering about experiences there.
The basic answer is no, you don't have to buy locally, and you probably, I hate to say it, you probably shouldn't, because, well, especially here in Australia, we just don't have the stock in place. I mean, we have RS components here, we have Farnell here, but very, very little stock locally, and they're generally more expensive than your DigiKeys and your Mousers. So I'm going to design my product almost always, even in that, 1,000 volume, I'm still going to design it around DigiKey and Mouser part availability. And if I think it's a key critical part, I will try and maybe source a reel somewhere else from one of the they're usually online American distributors, and like onlinecomponents.com or something they've called. I get a bit of stock from places like there, but generally, no, I'm going to design in the Farnell, I'm going to design in the Mouser and the DigiKey, because they have the most massive stock available anywhere in the world. And the scale of parts that they have is just phenomenal, and you can trust them. If you can see exactly how many parts they got in stock. You can get alternative parts, and you can do all sorts of stuff. You know exactly what you're going to pay, and because you've used it before, it's going to get through customs, no problems at all. In the case of Australia, anything under $1,000 just sails through customs. You don't pay any duty. There's no hold-ups, anything like that. Anything over $1,000 will automatically, $1,000 including shipping, will automatically get flagged by customs. So there might be a couple of days delay there until they contact you, and then you pay your import duty and GST and things like that. But no, I'll just order multiple things under $1,000 and get them here. Even if I'm manufacturing in China, I will get Mouser and DigiKey to ship the stuff here so that I can double check that it's the right stuff and got the right number, and then package it all up. And then once I'm right with the boards and everything else, I'll get everything shipped here, the blank boards, the boxes, the whatever, and then ship it off to my manufacturer, either here in Australia or overseas. I don't deal with local component suppliers, the Arrows and the Avnets. I gave that up years ago now, like a decade ago, that, with online e-commerce and Mouser and DigiKey now so phenomenally good, I just gave up. I used to use Farnell and RS a lot more when they had a lot more local stock, but now they just don't. So I'm going to go for the lowest risk, trusted solution every time. Even if I have to pay a bit more, it's worth every cent. Like even you're talking about 300 volume or something like that. Yeah, it's nothing. I'm doing 1,000 volume plus, and I'm still ordering from the likes of DigiKey and Mouser for most stuff. The only component I source locally is the box, which is actually manufactured here in Australia, believe it or not. The little black Jiffy box that I use, I'm quite proud that that's actually manufactured here. And I buy that locally. I can only recall one little stock issue with that once, but they just churned out more, and I can get as many as I want. So no, when you get from these dealers, they're a pain in the ass to work with sometimes, and they don't have stuff in stock, and they claim they'll be able to get it. Oh yeah, I have that for you in a week. And no, you can't trust them. Trusting people is a pain in the ass, and I don't like it. I like seeing that it's all online. There it is. I can get my 1,000 parts. I can get a reel, buy it now. Boom. I know it's going to make it through customs because it's under that, and Bob's your uncle. So, yeah, easy. I just stick with the big daddies, even if it costs me more.
So here's another one related to that whole regional part thing that I mentioned earlier. This is actually, I was trolling Nice Chips because if you remember when I talked to the Macrofab guys, we were talking about how do you find about new parts, and Nice Chips is one of the subreddits where we had discussed. I hadn't been on there in a while, so if you can't tell, I'm trying to find links I don't think Dave has talked about, so we have a lot of back and forth here. On the Nice Chips thing, there was actually a link to 41j.com, and I can't quite figure out who it is. It's someone that works with Akiba, who is from Freak Labs, who's been on the show a couple times as well. I assume this person is on the Hacker Farm. I apologize, but anyways, the other thing that I loved, here we go, Nava Whiteford, sorry. Anyways, I love that this blog subtext is, if I get 3,000 visitors a day, my wife says I can buy an electron microscope. And you want to help me buy a SEM, don't you? So we can definitely help with that at least. Anyways, this is all about the CL0116 solar lantern controller IC. I had actually never heard of this before. And if you click over to the data sheet, it is most definitely, this is chip link semiconductor. This is like a Shenzhen semiconductor number 5. It's the kind of chip where it's super cheap. But it's made in such quantities because this is a solar LED lamp controller, right? This is used in those little garden lamps that, they have the tiny solar cell on the top, and then underneath there's usually just a single LED and then a battery, and it's just storing power for the day, and then basically it's outputting that once it senses that it's dark out, then it just turns on, it switches over from battery power and turns on the LED at night. So anyways, this is a really interesting little part, TO94 part. But basically, it's just a switcher. It's a boost controller, effectively. And someone in the comments on Reddit was talking about how you can basically use these as a joule thief because it's doing the same thing. It's sipping power from a solar cell, and it's trying to basically boost that up to something usable, both for charging a battery and then also possibly lighting an LED directly. On the actual blog post, this is about a little a flower with LEDs on it. And so what I wonder from you, Dave, is do you know about any other ways to get this stuff? I was thinking maybe like AliExpress, or if you're trolling some of those places, like you can kind of find this stuff. But I have been thinking about a lot of these, there are, like, so I mentioned the regional parts, but like so many in China are just inaccessible to me. Like, unless you're in the, you're on Chinese datasheet sites, or if you know what you're looking for specifically, or if you're trolling the markets, then maybe you could find it. But it seems like so many of these things are just kind of out of my realm anyways, that I don't even see a lot of these. And there was some interesting stuff like this. This is probably really low cost, and it's doing something interesting. So I was just wondering if you hear about that, maybe forum or something else.
This one's really interesting because it really is, as you said, quite difficult to find out and know about this sort of stuff, because we're always trawling through DigiKey and Mouser when we go designs, and we'll like click around and hyperlink everywhere. Oh, look at this. Oh, what's this category of chips and things like that. And there is no real repository of what's available in the Shenzhen markets. What are these farty novelty toys? What chip is using? There's solar power light. What is that one using? And there's countless. I'm sure there's countless custom ASIC chips out there doing really cool stuff that could be very useful for your design. But there is a problem you need to be aware of, is that it may not be available tomorrow. So if you're designing a commercial product that might have, a 5-year product lifespan or something like that, you've got to be real careful buying these chips. But hey, they might be cheap as chips, so that you might go, hey, I'm going to buy a 10-year supply of these puppies because they're 10 cents a pop. And I'd highly recommend you do that. If you find a chip you like and you think you might sell 1,000 widgets, buy 50,000 parts or something like that. You don't know where it's going to lead. Don't just, I'm going to make 1,000, so I'll buy 2,000 of them. No, buy 10,000, 50,000, something like that. Just include it, absorb that into your cost of your product. I know I've gotten completely sidetracked here, but it's an important issue. These chips are great until you can't get them anymore. And that was always the issue with Maxim, for example, was the famous example. They had these fantastic chips before the internet. I had my bookshelf full of Maxim data books. They'd release like every 6 months, or was it 3 months at one stage? So releasing so many chips, like 600 chips a year. And they would release, it was so many that they had to release update data sheet, like 6 monthly updated data books, like 1,000-page data books with the latest data sheets for the 100 chips they've just, the 200 chips they've just designed, and they'd have them in categories, and that was so wonderful. And it was the greatest thing since sliced bread, Maxim, with all their custom ICs. And then, you design it in, you get all excited, and then you can't bloody buy the thing. That'll be a 40-week lead time, sir. Thank you very much. And it's like, oh, great. There goes my whole product idea down the toilet because nobody else makes a compatible chip. You need, a dozen chips to engineer a solution that, they just made available so easily. So this is great. And I'd love to see some sort of repository, the Reddit list you talked about. I think I visited once, haven't been in a long time, nice chips. Someone should have nicechips.com or something like that, or weirdchips.com. And then just have a repository and link in data sheets. Data sheets are often hard to get and things like that. So that'd be really terrific if someone can take that by the horns. But yeah, there's probably not going to be a lot of love there in return. You have to do it for just because you want to get it done. But that'd be great if there was something like that available. But yeah, just be aware of these things. Great for hobby projects, things like that, and for dozens of and things like that. But no, if you're in the serious end of town, designing commercial products, really be careful doing this. Unless you are designing a novelty farting toy, that's going to be manufactured in China and sold through the local $2 shop, then that's fine. Yeah, they generally are designed around one big batch thing. They'll make this chip and then they'll sell it. These lanterns could be different. These have a much longer lifespan, so they might have designed this 5 years ago and they're still flogging off that chip. So, but yeah, that's a bit more generic. But just be careful of the real specific ones. You could come a gutser.
So my last one here, we're only doing 5 each for people that are listening at home, but my last one here is actually taking advantage, it's probably not going to work out like this, but it's taking advantage of the fact that we're not talking to each other because I can harp on about revision control, and me and Dave don't really see eye to eye to that. Now, Dave is going to get the last word on this, and that's really how it goes, is whoever starts the conversation doesn't get the last word, which is kind of interesting. But anyways, I actually asked about on Twitter if people had worked on a team that doesn't use revision control for hardware, and whether they had or why they don't. And it was interesting. I actually love this is one of the things I love Twitter for. It's just kind of getting a lot of feedback from experiences and then conversations about different things. And yeah, it seems like a lot of the software people that are doing hardware, of course, are using it. The ones who are in teams that don't have revision control are basically stuck, right? I mean, if you think about, especially if you are a junior engineer and you want to use revision control, but you aren't in charge, right? It's like you can only harp on it so much before you just get knocked down and they're like, shut up, junior. And so that's tough too. And then there's, various levels of what they're using. It's not like everyone's using, SVN or Git or anything like that. Some people are doing it just with physical backups, right? They write, they zip up the file, they add a date to it, and then that was one of them. Jonathan actually was called in before, and he said they have a text file with the details, right? That is revision control. It's just not in a control management software type of thing or whatever they call it. And so, yeah, I mean, like that is tracking as long as that's only as good. Really, any revision system is only as good as if you're using it or not. And we've talked about on the show as well that if you're just using Dropbox and you're saving stuff in there, it's sometimes better than nothing. But being able to actually see why you're making changes and having that kind of that effectively that text file is like the traveling document why you made changes. Now, the reason I brought it up as well is because we were talking to Robert last week, and I was thinking about, I was actually talking today to someone about 6+ layer designs and how those are 6 months and stuff like that. And you talked about, you, Dave, and talked about working on these designs for like 6 months sometimes. And I think that's actually really an interesting piece, especially because you must have been tracking that somehow, right? I mean, there's some of it is just you have to get stuff, point A connected to point B, and that is really difficult. And but then, once you get to a certain point, and an engineer comes in and says, "Oh no, we need this chip over here because of RF or whatever the change is," then that you have to kind of track that over time and say, you either have to justify it to your boss or justify it to yourself when you're documenting later. So I guess my question was, how were you documenting that stuff? Revision control is one form of documentation, but obviously you were doing that anyways. So maybe you were just keeping a lab notebook or anything else like that. I would almost put forward that a lab notebook is another version of revision control, depending on how you track where you are in the layout or anything like that. Obviously I'm a big fan of Git. I use KiCad, so that has the text files instead of like Altium has binary files, so that is actually really hard to compare one to another. But in reality, you're never really comparing, even with a text-based file format, you're not really comparing it there. So anyways, I guess my question for you would be, how do you actually document? This question has morphed as I started talking, as it often does when we talk to each other. But how did you actually document stuff over time when you're doing those big layouts? Because like I said, I was talking to someone about that today, about the 6 month plus layouts. So I'd love to hear more about how you were actually documenting that over time and how you dealt with that, because that's just a monumental task anyways.
I think you might be a bit confused with my position on this revision control thing. I'm totally for revision control and have used it in the past. At my former company, Altium, we used to use Subversion, the Tortoise plugin, and I used to love that thing. It actually worked really well. I loved it. But companies before, because Altium was a software company, right? So obviously that was when you go into a software company, that was the first software company I worked at. Even though I was a hardware engineer at a software company, we just were sort of forced to use that. And I really got to like it. And that was my first real experience with a content management, control management system, CMS or whatever it's called, I don't know. With this revision control, I've never used Git for that sort of thing, because that's what Altium used, the Subversion system. But at previous because I've worked at hardware companies previous to that, they didn't really have a Git or a Subversion type system, so they really didn't have. Well, no, actually they did way back before the internet. Okay, before like 1995, my first full-time PCB layout job was in '94, I think, at GC Marconi. Or was it 95? Anyway, basically before I even knew there was such a thing as version control, it was all the hardware design part of things was actually done on paper. So it'd have these big A3 graph papers in these big binders, and we'd have shelves full of these binders, and we had effectively a revision control system there. Each project had its own unique code, and then each part of the project had its own subcode, and then you'd have revision, A, B, C, D, or whatever it was, and you would keep these in these folders, so you could go to the folder and you could physically flip through all these A3 graph papers where you'd actually, if you drew a circuit, you'd draw it on the A3 graph paper. If you had a data sheet that you wanted to include and mark up, you'd actually photocopy the data sheet on the photocopier, stick it on there with glue, and then mark it up, and you cut and pasted all this stuff onto physical paper. And that was a revision control system in itself, and that worked fairly well, and you could copy it. You could put the whole, some secretary would often duplicate the entire sets and move it across facilities or something like that. And that was revision control. Was very handy. You'd go back. As far as PCB design goes, as I said, first full-time job back in 95, before the internet, before version control, the company didn't really have anything for that. It was just up to you as the professional doing this to just get your job done. And as you were talking about, I would do the subdirectories, with the different dates or whatever, or I'd call them in my own internal versions, so to speak, before I got to release. And I was literally working on a 4 to 6 month layout board, huge one. And you would do that internally because you felt you had to, because you had to go back if you, screwed something up. And I just did it that way using subdirectories, and it worked just fine. It got me out of trouble a few times, and if I hadn't have done that, I would have been in a spot of bother. It would have taken me a lot longer, would have had to start again from scratch or something, or, it would have been much more difficult. But it saved my bacon quite a few times. But there's nothing wrong with the subdirectories and, based system, as long as you're disciplined enough to do that. And I would do that often several times a day. If I'm making huge progress, if I'm working on a large board and I make a strategic decision to route this direction or place parts over there, okay, I know this is a big change, so I'm going to back this up first. And of course, that would go onto the back of the internal intranet, so that was all backed up and things like that often. But it was just my own system. And yes, I would document that either on paper form or in a file form, or it's just pretty obvious, like, internal revision 1, it was all in the file name and the subdirectory names and things like that, and that just worked fine. There's nothing inherently wrong with that. Yeah, there are better tools these days for things like that, but I just wasn't aware of them back then before the internet. And the company I worked for, you typically take on the culture of the company that you move into. And as you said, it is, shut up, youngster. It is difficult to enact change within a company, especially major, changing the way people do things. That's really difficult. Engineers don't like change.
Well, that is a good point to end on. I wonder if engineers don't like change, or really listeners to the Amp Hour don't like change. That is the last of our segment, our decoupled conversation. So that was different. I think the interesting thing is that when people say they don't like that me and Dave argue, this is exactly what I'm going to point them to. If they don't like this show, or if they do like this show, this is basically what it sounds like when you don't have interaction back and forth, or if there's no delays either. So, like I said at the beginning, if you liked it, don't like it, I don't know. This was basically us trying a new thing because of our situation, but, it's always good to innovate. 317 shows in, you never know. Many thanks to my co-host Dave, who I did not get to talk to this week. Thank you to people who submit to our subreddit. That is always helpful. That's reddit.com/r/theamphour. That's where we keep all of our links, including stuff we don't get to talk about. It's a good place to discuss stuff. It's a good place to post links. It's a good place to see the stuff we missed. And thanks to you, our listener, of course. We especially love our Patreon sponsors. We're very grateful for them, and we love that people still are listening. Like I said, 317 shows in. Our astute and longtime listeners of the Amp Hour may recognize that in between music that I used as editing, as ways to separate out the talking points this week, that is actually from Chloroform the Amps, which is the song that was donated to us by Paul Stevenson. Thanks much to him. We've continued to use that theme song for about 200 plus episodes now, so we do appreciate that too. We'll be back next week with another episode. Thanks for listening.
So, yeah, easy. I just stick with the big daddies, even if it costs me more.